This is the last day that I'm going to give you some content, and this is not new. This is just stuff we haven't done for ages, and we need to try and put some stuff together that we've already done before. So remember when we did our probability topic, there were things where, let's say that we have a deck of cards, and what's the probability you get this, this, or this? So some of the time we were putting the cards back in the pack after we looked at them, and some of the time we weren't. So it's really important that you pay attention to the words with or without replacements. That's going to change how you calculate probability, whether you look at something and put it back in and have another go, or you look at something, leave it out, and then have another go. Those are different things, and we're going to calculate them differently. We're going to do an example in a second. I also want to remind you of some language to do with probability. If I want the probability of A and B, or A or B, what sign do I use between the probabilities of A and B? Multiplication. What about A or B is addition. So it's really important that we can interpret the questions and know what we're being asked to do. So I especially suggest with probability that you just read all the questions twice. Just make sure you know what you're being asked to do. You're allowed to highlight your question paper in exams. I know that Shari is obsessed with highlighters and she's always highlighting her exams just to make sure she's actually understood the question properly. If Shari in grade 11? The only Shari at the school? Little sister? I think you mean big sister. Okay, I am going to do an example of this. Now, some people try and hold big probability questions in their heads. That is never a good plan. There's always a lot of information and you don't want to mess it up. What are some of the ways we can draw out probability questions using diagrams and stuff? What have we got? Yeah, what's that called? Tree diagram. Sideways tree diagram.
Family tree.
Definitely not a family tree. What else? Yeah. Boo. What other types of diagrams are there? I don't know what that is. Yeah. A sample space. So a sample space is just listing everything, right? Sample space just means list all the options. List all options. Josh, what do you got? Venn diagrams, absolutely. Venn diagrams are helpful. Pie charts. Bar charts. Line graphs, not so much probability, but we'll write it down anyway.
Stem and leaf diagrams.
Stem and leaf plots. Nah, I'm gonna say that's not so much probability, that's statistics. Hey guys, stop shouting. Amrita. Frequency table, again, that's more statistics than probability. How about a two-way table? Two-way table might be heads and tails and then heads and tails, right? We make like so double head, head tail, double tail, tail head, right? Shh, guys. So you might have a two-way table. These can be really useful. I'm going to stick with tree diagrams mostly today because they are super useful. We're going to do a couple of different examples of things and we're going to make these complicated questions, all right? So I have a bag with, that does not look like an eye, with green, blue, and black marbles. I'm going to have 2 green marbles. I'm going to have 3 blue marbles, and I'm only going to have 1 black marble. So what this means is that the combination of things I can do are not going to be equal, right? Because there are different numbers of everything. So I am going to pick 2 marbles without replacement. There's a very low chance. So what I'm going to do is I'm going to draw my tree diagram. I'm going to have 3 options. Actually, what I'm going to do is I'm going to draw that a bit bigger. Replacement. Okay, I'm going to put that over here and I'm going to try and draw it a little bit bigger. So this is green. Oh, geez, why did I make green, blue, black? Now, shh, guys, focus. So I'm going to pick two marbles. So what have I represented here? I've just three. Let's talk about it in terms of the question. Right, I'm just picking a marble, right? I need to pick a second marble. So there is going to be a second option that comes off this. This is going to be green, blue, black, green, blue, black, green, blue, black. So that's true. So what I'm going to do now is I'm going to write some probabilities on these arms. Guys, focus. I'm going to write some probabilities on these arms. So there's only 1 out of 6 marbles that are black. How many blue marbles are there? 3 out of 6, which is half. Green is 1/3, 2 out of 6. Now, if I pick a green marble, there were 2 of them in the first place. How many are left? There is 1 left and there are 5 marbles left. If actually what I'm going to do is I'm just going to write these as out of 6 just to make life a bit easier. There are 2 out of 6 green marbles and 3 out of 6 blue marbles. If I pick a green marble, the second time I want to pick a green marble, there is 1 less green marble. So there's only 1 left. And there are only 5 marbles all up because I've taken 1 out. How many blue marbles are left if I've picked a green marble? There are still 3 blue marbles because I haven't done anything, but there are only 5 marbles still all up because I've taken 1 out. How many blue marbles do I have left? Sorry, this is black. There's still 1, but there are 5 marbles altogether. See how my probabilities are changing the second time. For the green one, how many green marbles are left? There are 2 green marbles left and 5 altogether. How many blue ones are left? 2, because I've already taken 1 out of 5 and there's still 1 black. Guys, please stop talking. Okay, second time for the green one. There are still 2 because I haven't touched them. Blue ones, there are 3 left out of 5 and black, okay, 0. So there's no chance that this possibility could happen. So what you now need to do is then think about what is the question going to ask you? So for question A, I want 1 green and 1 blue. So the first thing I need to do is figure out all the paths I'm allowed to take. I want a green and I want a blue, so I'm allowed to take this path, right? That gave me a green and then a blue. This path is going to give me a blue, then a green. I did not specify the order. I didn't say a blue, then a green. That again, that's a really important distinction. I'm saying and instead of then, because otherwise the order would matter. If I say and, it doesn't matter. So I want to get a green and a blue. So what do I do with these 2 probabilities? Multiply them, right? 2/6 is getting a green and 3/5 is getting a blue, which gives me 6/30, which is 1/5. Okay, the other one I'm allowed to do is 3 out of 6 and then 2 out of 5. So I get 6/30 again, which is 1/5. So what is the probability that I get a green and a blue? It's 2/5 because think about the language. I'm allowed to have this or this. So that means altogether, my probability of getting a green and a blue is 2/5. This is why tree diagrams are really useful. They are good visual aids. You can pick the branches you want, then add up the things that you need. Let's look at a Venn diagram one. So